What do you call a fake noodle? An impasta! Ha! Anyways, this is 3-2 scatter plots and predictions for Math 8. So we're in Unit 3, Lesson 2. And we're going to be using scatter plots to make predictions. Your I can statement is to draw a trend line that fits data represented in a scatter plot. And then this is the real important part. Use that trend line to extrapolate and interpolate information. Our agenda is going to be to go over some vocabulary and do an example problem. That's all we got going here today. Shouldn't be too long of a video. And once you understand the trend line, it's actually fairly straightforward. So some quick definitions. A trend line is a straight line that has about the same number of data points above and below it. And I'm going to fix this little typo here real quick. So the same number of points above and below. And we're going to see that on a scatter plot that we use in just a second. So when you draw a trend line, you want it to follow the data points. When you extrapolate something, you're going to be using that equation of the trend line to predict values that aren't shown on the scatter plot. So big values. Notice this is a verb, using an equation. We're extrapolating something or interpolating something. We're using a trend line to find a value between 2 points of data in a scatter plot. All right, so here's our one example. It says draw a trend line of this data. And we've got some data of Joyce's running. And so here's Joyce's distance, and here's the time it takes her. Now I'm just going to graph a few points as kind of a reminder of how we graph points in a scatter plot, and then I'm going to switch it so you don't have to watch me graph them all. I'm going to graph this first one here, this one, and the one here. Okay, so it looks like it took her 38 minutes to run 4 miles. So I'm going to find 4 miles on my x-axis, and I'm going to go up just below the 40 and make my data point. This right here, if you notice how it's scaled, every time you see this line on the y-axis, it's 5. So this right here must be 35. So 38 to be just before 40, in between 35 and 40. 17, just below the 10. And 326, just above the 25 mark. Okay? Already, even though I've only graphed 3 points, it looks like we're going to have a positive association. And that makes sense because the longer you run, the more time it would take to run. That's a pretty basic concept. So we're going to probably be seeing a positive association of this data. As the distance goes up, so is the time. Let's see. All right. So this is a kind of a completed scatter plot of that data. And we're going to go over how to do this. So let's first start by drawing a trend line to fit the data. That's our first direction here. So I'm going to draw a trend line to fit this data. And I'm going to move it over just a little bit if I can. Oh, I think it's locked. So let me grab a line here. Let's use the color yellow. I think yellow will work good. Okay, when you draw a trend line, you want to think, okay, where am I going to start this trend line? And in this case, we can just think about what's going on, and we know we can start at the point 0, 0 at the origin, because if she runs, it's going to take her 0 time to run 0 miles, and if she hasn't started running, we're going to be at time 0. So we know we can start right here at 0, 0, even though there's not a point there. And then when you draw the line, you want to try to get the same number of points above the line as there are below the line. So if I go right about there, I've got 1, 2, 3 above, 1, 2, 3 below, and about 3 on the line. So that line fits that data pretty good. And that's the whole point of a trend line. Now there's going to be a margin. I mean, if my line was moved over just a little bit to the left, it'd probably still be okay. And you want to think about how far away the points are from the trend line. So we're kind of just eyeballing this. There's not like an equation that we're using. Line of best fits do have very specific there's a very specific way you do a line of best fit, but we're not worried about that. We're going to eyeball it, okay? So now that we've got a trend line here, we just check it to make sure it's legit, make sure it looks good. There's the same number of points above it as below. We can start making predictions. And there's 2 different kinds of predictions. And that's where these weird words come in. So to interpolate something, like extrapolate, but we're going to do it between 2 values, we would use the trend line to help us. So the time it would take for Joyce to run 3.5 miles. So we're going to interpolate that. The reason it's called interpolate is, or I don't know how you would pronounce it, maybe Yeah, I don't know. I know this is extrapolate, of course, but I might be pronouncing that kind of funny. So you see 3.5 right here on the miles. That's between a 3 and a 4. We have data at mile 3. We have data at mile 4, but we have no data here at mile 3.5. So we are interpolating this. We're finding information in between two given points on the graph. So that's why it's an inter prefix instead of an extra prefix. So when we do that, we find the 3.5 because it wants to know how long it would take. We go up to our line of best fit. This is where we hit the line. Then we look left over here and see how long it would take. According to our line of best fit in the graph, it would take about 35 minutes to go 3.5 miles. Okay? Now, to extrapolate something, that means we want to know how long it would take to do something that's beyond what's shown on the graph. So how long would it take her to run 7 miles? The graph only goes up to 5, so we have no information on here that would tell us how long it would take her to run 7 miles. So this is where things get interesting. This is where we find the equation of our line of best fit. So this is just a normal line. It's a linear line of the data that we've drawn. So we can plug in the slope and y-intercept into the slope-intercept form, y equals mx plus b, and we'll have an equation. In this case, obviously, the y-intercept is 0. So we know b is going to be 0, and we just have to solve now for m. So y equals something times x plus 0. So what's the slope? So I'm going to find 2 points on my graph that are pretty close to an intersection. Sometimes if your line, isn't exactly at the across of an exact point, find one that's the closest. This is pretty close. So I'm going to count my rise, 5, 10, and my run is 1. So my slope must be 10 over 1, which is just 10. I'll write it as 10 over 1. And then I'm going to rewrite this equation in a second. A quick note, though, some students I've noticed when they do this think we're finding the slope between any two data points, like this point and this point. We're not. We're finding the slope of the yellow line of the yellow line I drew. And so we're finding the slope of the trend line to write an equation of the trend line. And now we can rewrite this equation as y equals 10x, because 10 divided by 1 is 10, and we don't have to add 0. So to figure out how long it would take Joyce to run 7 miles, we simply plug in 7 for x on our x-axis here, and we would get, y equals 70. Or in other words, it would take her 70 minutes to run 7 miles because she's averaging 10 minutes per mile. And that's what the line of best fit did for us when we found the slope of the line of best fit, when we found the slope of it, we found the average amount of time it takes her to run 1 mile. And some of the data, makes sense. As she started out on mile 1, it didn't quite take her 10 minutes, but as she went, she got a little more tired. The average is about 10. So we're extrapolating that out for 7 to figure out 70 minutes. So anyways, that's how this is done. Remember, a trend line is just a line that fits the data. It's linear. So you can find an equation of that line by finding the slope and y-intercept and plugging them in. And then we're going to make predictions, these two kinds of predictions right here. And I'm going to click to the next slide for your number clue. Excuse me. The number clue is it's even. All right, guys, good luck.